So for question 8, we have a bag contains 1 red ball, 2 green balls, and 4 yellow balls. A ball is taken from the bag at random. The ball is then put back and a second ball is taken at random from the bag. What is the probability that A, both balls are the same color, B, no yellow balls are taken out, and C, at least 1 yellow ball is taken out? So I've already partially made the tree, and to show you where these numbers came from, to work out the probability of a red ball, when you take one out, we have 1 red ball, and we have a total of 7 balls in total. So 7 balls total. So your chance of taking a red ball is 1 out of 7. Your probability of taking a green ball is 2 out of 7. And the probability of a yellow ball is 4 out of 7. So that's your probability for any given ball that it will be that color. So I've already labeled 1/7, 2/7, and 4/7 for red, green, and yellow. You need to repeat those numbers across the tree. So this is your first ball, and this is the second ball. So we repeat the numbers. So 1 on 7, 2 on 7, 4 on 7, 1 on 7, 2 on 7, 4 on 7. So our outcomes, take a look at your tree and you can write them down. So we have red, 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 green, red, yellow, green, red, green, 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 yellow, yellow, red, yellow, green, yellow, yellow. So these are not all equally likely. Okay, so just be aware of that, and you'll see that when we actually calculate the probabilities. So we multiply across the tree, remember? So 1/7 times 1/7 is 1 on 49. Then we'll get 2 on 49. Then we'll get 1 4 is 4 on 49. Then we get 2 on 7 times 1 on 7, that's 2 on 49. 2 on 7 times 2 on 7, 4 on 49. 2 on 7 times 4 on 7, 2 4s are 8 on 49. Then 4 on 7 times 1 on 7, 4 on 49. 2 4s are 8 on 49. 4 4s are 16 on 49. So as you can see, the probabilities are mostly different for every outcome. So now we go to our question. What is the probability that both balls are the same color? So we go down to see which outcomes have the same color. So red, red, green, green, and yellow, yellow. So we write those probabilities down and add them. So 1 on 49 plus 4 on 49 plus 16. 49, what is that up to? 20, 21. So that's going to be 21 on 49. And you get your calculator and simplify that, or do it in your head. 21 divided by 49 will be 3 on 7. So this one does simplify. So at this point, we can simplify our answers. So that's going to be 3 on 7. So a bit less than 50% chance to get the same color on the balls. Okay, no yellow balls are taken out. So you need to go down and list the ones where you have no yellow ball. So that's this one, this one, this one, this one, and they all have yellow, don't they? Am I missing any? No yellow ball. So red, 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 green, green, red, green, green, and the rest have yellow balls. So we have 4, 5, 6, 7, 8, 9. So that's going to be 9 out of 49, just doing in my head. You see, just add up those ones in here. So 4 plus 2 plus 2 plus 1. We'll give you 9 out of 49 for that one. Okay, at least one yellow ball is taken. So we need to look at all of those outcomes that have one yellow ball at least. 2 yellows is fine. So let's circle these ones. So at least one yellow ball. This one, this one, this one, this one, and this one. So actually, it's going to be the opposite of this one, isn't it? You see, this is no yellow balls are taken in green, and this is at least one yellow ball. So if you want to save yourself some time, we can go 1 minus 9 on 49 from this question here. And you should get, what's that? 1 minus 9 on 49. So you will just check if it can be simplified. So that's 40 on 49. So the other way to do that would be to actually add all of these in yellow here. So if you want to add them up, that's fine. I'm just doing a little bit more quickly because we know all the probabilities add up to 1. So if I know those in green, I can calculate those in yellow using this method here. In question 10, on his way to work, Paul has to pass through 2 sets of traffic lights. The probability that the first set of lights is green is 0.5, and the probability that the second set of lights is green is 0.4. What is the probability that both sets of lights are green? And calculate the probability that neither sets of lights is green. So I've already drawn a part of a diagram here, a probability tree. And the first set of lights I put here as this column here. And the second set is here, and we'll fill the rest in. So for green light here, and I'll mark that as not green. So we need to continue those letters in our diagram. So we're going to have green here, not green, green, not green. And so we need to go back to the question to find the probabilities. Okay, the probability that the first set of lights is green is 0.5. So this is 0.5. Now, if it's half a chance it's green, set 1, then it must be half a chance it's not green. Those 2 probabilities have to add up to 1. So when you're doing these diagrams, make sure your pair of numbers on the branches add up to 1. So each pair must add up to 1. So these 2 that are marked here must equal 1. And it says that the second set of lights of green is 0.4. So if this is 0.4, this green is also 0.4, but this is not 0.4. So remember, as I mentioned, this number 0.4 and this number must equal 1 when you add it, because there's no other color that the light can be. It's either going to be green or not green. So this has to be 0.6. This is where many students make error, so be aware of this. So 0.4 for green, 0.6 not green. Got it? So every pair, this pair, this pair, and this pair must equal 1 when you add those numbers, okay? So if they don't, you're going to get probabilities that won't add up to 1 when you finally do a check. So what do you got here? So 0.5 times 0.4, 5 fours are 20, 0.2, okay? 0.5 times 0.6, 5 sixes are 30, so 0.3. Actually, these are the probabilities, aren't they? So let's stick those over. So 0.2, 0.3. The outcome was green, 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 not green. This outcome was not green, green, and not green, not green, if you're lucky. Both will be, well, if they're both green, you'll be lucky, won't you? So, okay, not green, green. So 5, 4, so 0.2 again. And not green, not green. 6 5s are 30, 0.3. So when you add those decimals, you can see you get 1.0. So more than likely you have this done, you've done this correctly. So that is one way to check. It's not 100% sure that you've done it correctly, but this number should tell you more than likely you've done things okay to this point. So for A, what's the probability that both sets are green? So then we just go to where we've got green, green. So we're going to have 0.2, 20% chance they're both going to be green, just 20% if you like percentages. And what is the probability that neither set is green? And that will be the last number here. Not green, not green. So that's going to be more likely than having them both green. So that's going to be 0.3, which is 30%. Okay, they could be converted to percentages. So you got 20%, 30%, because they're nice numbers. 20%, 30%.